Yeah, that one's pretty awful, but you know, this one's all right. Logarithms. Now, when we deal with logarithms, they're actually kind of an important thing because we can do this. What's that? 4. Okay. Okay, so far so good. What's that? Okay. Who do you don't like this? What does that equal? 1. Well, it's anything but 1 power up, first power. Well, it'll be 2, yes, in this case. So the logarithms allow us to solve for exponents. Logarithms allow us to work with exponents to be able to figure out what value would give us this. Obviously, it has to be somewhere between 2 and 3 to make it work, but where? Is it 2.5? Is it 2.2? I don't know. No say. Exactly. So that's where logs come into play. So logs allow us to work with these things. And excuse me. As we get going into logs, there's going to be a couple of rules. Logs are, how do I want to write this the easiest way? When you see a log, you've seen the button on your calculator, log base b of y equals x, and then b to the x equals y. These are what you call equivalent statements. Basically, you think of it this way. The b is a base, it's lower. B is a base, it's lower. Okay. This of what value? All right. So if we think about the one we just had up there a second ago, where it said 2 to the third was 8. What's my base of this? 2. Okay. The exponent is what? 3, and then the 8 is the y value. So what happens here is that you can do this. This means the same thing as log, excuse me, base 2 of 8 is 3. Log base 2 of 8 is 3. That's what that means. Okay? Now, obviously, when we get into some of this stuff, hi. Charlie. They forget to give you guys a what does Y stand for? No idea. That's awesome.
Our teacher was supposed to be teaching us tomorrow is gone, and they can't find the permission slip, so we all have to get new permission slips for tomorrow.
I'm going.
I'm just trying to figure out. What? Oh,
okay.
All right, cool. Yes, I'll get it now. I just look back there, just got a tape recorder out going.
You know what he was asking, right?
If you actually know it, no, it doesn't. So anyway, so logarithms are going to allow us to solve those exponents to make things work. When you say it, we say it as log base 2 of 8 is 3, log base b of y, and so on and so on and so on. So works out pretty cleanly. There are a couple properties that we use. These are the 2 main properties that we use all the time with logarithms. Log base b of 1 is always 0 because b to the 0 power is always 1. This b could be anything. Okay? The b values will always be positive values. All right. And then the other one is base b of b is 1. So when we get to working with graphs of these things, these would be basically the only 2 values we're going to use, 0s and 1s. Remember, excuse me, this is new, this is weird, you haven't seen this before. With a little bit of work through it, it goes by rather easily. Logs sound very out there, but as you get working through them, they're very simple to work with. Yes, ma'am. Yeah. Yep. So now if you think about it, there were times when we had to solve for different exponents If you didn't know what your variable was in the exponent, you didn't know what nth root to take. This kind of takes care of that, if that makes sense. Okay, so what we'll be able to do is we'll be able to figure out that equation of 2 to what power is 6. Because we'll learn how to undo the base to drop the exponent. All right? And in order for us to do that, what we do is with the property, obviously we haven't gotten this far yet, is we would log both sides. Okay? So in your calculator, if you want to do this real quick, I want to say it's alpha window 5. Yeah, no, that's a different one. That's a different one.
Yeah.
Is it alpha window 5?
Yeah.
Okay. Alpha window 5. Let me pull up my calculator here real quick. We're going to get to this here eventually. This is also going to be a calculator stuff because a lot of the properties of logarithms you don't need to use the calculator for. But when we get to solving the equation stuff, we're going to need to use the calculator because you're going to get more equivalencies. So if I looked at this and I wanted to figure out what 2 to what power is 6, I would type in alpha window 5 and see how it says log base. Your cursor is blinking. What number do you think I had to put there? We'll put a 2, okay? Because that's what we're doing. And we're doing log base 2 of 6 to figure out the exponent. And there's my answer, 2.58 change. Okay. So if I did 2 to that power, it should equal 6. There you go. And now there's logs. It's impressive. All right. Like I said, they're not terrible to work with. It's a different way. It takes a little bit of time. So what we're going to do here is going to rewrite them between the two different forms. One form is called logarithmic because there's the word log in it. Convenient. And then we're going to rewrite those as exponential. Now, the idea here is just to practice between these two statements because they are equivalent to one another. It'll help us to simplify logarithms in the long run as we go through it. Remember, it says log base 2 of 32 is 5. Log base 2 of 32 is 5. That means 2 to the 5th is 32. That's how that works. Okay. So as we go through to rewrite this into an exponential form, this means we get 2 to the 5th is 32. Eventually, what's going to happen is that you're not going to know this. So you'll have to understand what it's asking. It's asking 2 to what power is 32. All right? And when we do these equivalencies, those numbers have to be clean. Otherwise, it's just not going to work. Right? Next one says log base 5 of 1 is 0. Correct. 5 to the 0 is 1. Anything to the 0 power is 1. This means 5 to the 0 is 1. Right? Excuse me. Log base 10 of 10. Now, log base 10 is your standard log. It's what we call common log. On the calculator, the button that says log is for base 10. What we did a minute ago, we changed the base to base 2. That's how you would change your bases in the calculator. Back in my day, we had to do what was called change base formulas because we didn't have calculators that did it for you. So we had to work with base 10 stuff and do a whole bunch of calculations. It wasn't difficult, even with our old calculators, we were able to do it. But when you see just the word log, it means that it's base 10, okay? So, like I said, the calculator button that you see just says log, that's base 10. You'll probably never hit that button. So this means 10 to the first power is 10. When you see decimals, log base 10 of 0.1. Whenever you see a decimal, I'm going to rewrite it as a fraction. 0.1 is what? 1/10. So this is the same thing as saying log of 1/10 is -1. That means 10 to the -1 is 1/10. Makes sense, doesn't it? Notice the base wasn't negative. Why is it just being the exponent? Right? And then the last one on this one, it says log of base 1/2 of 2 is -1. Well, that means, excuse me, 1/2 to -1 power, oops, is 2. Logs, they switch back and forth between log base and exponential. In exponential form, they work out rather quickly. And I apologize, you guys got to miss the log some. We should do it again, just to make sure you guys feel good about yourselves. Now this makes more sense to watch. Feel better about seeing that? No, that's not fake. That's real. It's Ren and Snippy. So what that song came from. Right there. Since we were saying, we just did all this. We need to do more words. We'll get to this. We're going to be asking the question, what's x? So go through it. This says log base 9 of what is 1/2. That means 9 to what? 9 to the 1/2 power is 3. So what we do here is we're going to use the equivalent statements of logarithms to know that this is 9 to the 1/2 power to equal x. Now, when you rewrite these things, when I try to type this in there, it's kind of hard to write fractions as normal top over bottom fractions, which is why it was a little slashy there. Obviously, and then with the 9, it doesn't do a very good job of what's called subscript, so that's why it just looks a little weird. Textbooks and everything else, it's pretty clean as you go through it. You'll be able to tell how it goes. But remember, this is just saying 9 to the 1/2 power. What's 9 to the 1/2 power? You guys already said it. 3. Okay? Again, it's not very difficult. It's pretty straightforward. Okay? We do a lot of this evaluation stuff where they're going to ask us to evaluate the expression, which basically means we're going to do all this non-calculator. So it's what's asking us is log base 3 of 81. That means you keep going back and forth between log form and exponential form. It's basically asking us the question, excuse me, by the power of what power of b gives you y? Yeah. So 3 to what power is 81? 3 to the 4. 3 to the 4. So this basically simplifies out to equaling 4. Okay. What power would you raise to? Now, the next one's a decimal again. Decimals are not fun. But what is that in terms of a fraction?
Not good.
Not good, correct. But otherwise it's known as 4 100ths, right? 4 100ths is how much? Which is 1/25. Now, if you look at this, if you look at it now, 5 to what power is 1/25? -2, very good, it's -2. You're on the right track with the 2's there. This means it's 5 to the -2 would equal the 1/25, so your answer is the -2. Okay. 1/2 to what power is 8? 1/2 to what power is 8? You gotta remember what you're doing to your fractions here.
-4.
It'll be negative, you're right, but it's -3.
3.
Good. Good. And then last but not least, log base 9 of 3. This one. It's 1/2, very good. 1/2. 9 to the half power means square root, so this is 1/2. All right. Working back and forth with logs and exponential form, it's pretty straightforward. It's not too crazy. All right. Excuse me. We're not doing that one. Inverses. Now, like we said, when we work with inverses, I'm actually running way ahead on this, so this is good. We can kind of, how do you undo logs? Well, there's going to be a new term called exponentiating. Ever heard of that before?
No.
So what happens here is we're going to be able to raise exponents. We want bases to drop. Basically what happens here is this scenario. Whenever you have, let me move this up a bit here. The easiest thing to think of is this. Log base b of b to the x. When you have these bases the same, they undo one another. And the exponent falls. Okay. So if this is log base 5 of 5 to the x, this would simplify to equal x. Okay. The bases undo one another. All right. Same deal with if you have, what was the other one I showed you here? Whenever you have, excuse me. This is where this exponentiation thingy goes. You raise it to an exponent to keep the bases the same. It's going to look weird when we do a couple examples. We're like, oh, that's it. Happens rather quickly. You'll see us rewriting to get in terms of the same bases. For example, if I say log base 2 of 8 to the x, I can't undo that at all because the bases aren't the same. So you'll ask yourself, how do you rewrite an 8 in base 2? It's 2 to what power? Third. Okay. So this is the same thing as saying log base 2 of 2 to the 3x. Do these bases undo each other? Yes, so it would simplify out to equaling 3x. That's the kind of scenarios that we're going to walk towards. That's the kind of stuff that we're going to work towards, not walk towards, work towards. Let's see here. So, for example here, we want to simplify these two. It says 10 to the log of 2. Now, are those bases the same? What's the base of that log? 10. So the idea, like I was getting at here, is the same thing. These two bases are the same. If those two bases are the same, whatever is left over drops. That's it. If the bases are the same, it drops. Yes, ma'am. Remember how I was talking earlier? When you have just log, it's implied that this is called the common log. Yes. So the common log is base 10. And they just don't write it. Okay? So on the calculator, this button here, which just hits log, that's implied that's base 10. So any other base that we need, we'd have to use that alpha window 5. And that's how you would change your bases. So anytime you just see the word log, it's common, which means it's base 10. And then same idea over here. This one says, this is where I was talking about a second ago about how do you rewrite that 9 as base 3. How do you rewrite 9 as a base 3? 9 squared. It's 3 squared. Remember, this is the same thing as saying log base 3 of 3 to the 2x. And now do those bases basically undo one another? And then that means your exponent falls. The way that this is going to work eventually is that when we start to solve equations of these things, in order for us to drop exponents and things, you'll have to log both sides to undo stuff and keep things balanced. It's just another way of solving equations, all right? We'll get there. It's pretty quick. Excuse me. So we just did the, all right, log base 2 of 64. Again, the idea is we need to rewrite 64 as a base 2. So we have to figure out 2 to what power is 64? What's 2 to the 5th? 32 times 2 is, so that is the same thing as saying 2 to the, so this is how you would write it. It's log base 2 of 2 to the 6, which means that your answer is 6. Okay.
Stop.
That's gross. All right. We'll come back to the 25 and the 5 there. Let's look at log base 6 of 1. What does that have to simplify to equal? Remember, it's 0. Yep. Because remember the rule we had way back. Oops, wrong button. I had it there. There was it. Remember that one? Okay. So b to the 1. So whenever you have log base b of b, where was I at? Lost. Okay. So this was your 0, because that means 6 to what power gives you 1? 0. Okay. And then the last one, it's 10 of the log of 4. What does that have to equal? 10 to the log of 4. 4. Because remember, these guys have the same thing here. The weird one. Weird one. Again, we want to think about it in terms of 25 to what power gives you 5. Yes, sir. Very good. Where do you get that? Okay. We're just evaluating, simplifying, and working back and forth. So this one gives you 1/2. Excuse me. All right. Again, this isn't too typical, I hope. I don't think we'll work on graphing today, though. Yes, ma'am. Oh, remember, this is the same thing as saying 10 to the log base 10 of 4. If those two bases are the same, it just drops. Okay. Yes, ma'am.
Wait, was that B again? Where did we get to?
9 is the same thing as 3 squared. And then when you're up the exponents, you just put the exponents together. Okay. That makes more sense. You're just rewriting that 9 as a base 3. So 9 is the same thing as saying 3 squared. And then you just keep the other exponent up there. No, that's pretty gross. Oh, I guess I should have moved this up a little bit earlier. Anyway, there is another log that we talk about. It's called the natural log. That deals with... What's that? Yes. It is real wood as opposed to engineered. So it's not like Pergo. It's hardwood floors. So when we're talking about the common log that we've been saying, that's your base 10. Natural log is log base E. All right, log base E is what we write as ln, log of the natural base. That's what the ln stands for. This will become a lot more prevalent when we start working with equations more so than anything today, because again, it's not something we're going to be able to simplify very cleanly, because as you remember, E is a gross number. So just going back and forth between natural log. Remember, natural log is the exact same thing as saying log base E. That's about as much as you get into this, because when we change, when you see a problem to simplify, it'll say natural log, ln of something. If you rewrite it as log base E, it becomes a little bit cleaner for a lot of the simplifying stuff that we do as we go through there. There's the button for the natural log on the calculator. I think it says, what is it? It says ln on it, right? It's right next to 4. So you'll see it there. And again, that's not going to be anything that we're going to worry about too much yet. We'll worry about that a lot more when we actually get to the equations later on. So let's see what else we're missing here. Because I don't want to graph today. Oh, we do inverses? No, we did. Okay. So I don't want to graph because that just gets a little messy for too much for one day. So let's see. Let's do. Oh, let me do this example real quick. Inverse. I want to do an inverse problem with a natural log real quick. Okay. And you'll get over it. So, real fast, just to show you an example real quick of how you work with inverses as far as natural logs are concerned. Remember, for the rule of doing inverses, you're flip-flopping x's and y's, and then you resolve. Okay? So in this case here, first step would be to flip-flop your x and y. So I'm going to have x equals natural log of y minus 1. Okay. From there, I always want to rewrite as log base e. And the reason why I want to do that is so that way you see how the inverse parts of this works. So again, I'm going to rewrite this as x equals log base e of 1 be y minus 1. Oops, y is pretty bad. All right. And now I need to undo that base of e. You make it a power. Okay, this is where we call, this is that idea of what I was saying earlier, what we call exponentiating. So remember the rule was, if I raise this to become an exponent, e to the log base e, those bases undo each other. Those bases undo each other. So now that junk in parentheses falls. On the other side of the equation, then I have e to the x. Okay. Does that make sense? Mm-hmm. It looks a little weird, but that's the reason why we rewrite this as log base e, so that way you can see how that works. All right? What's that? No, because the e is now becoming the base, and I'm raising all the other stuff to exponents. So the base stays down. The exponents go up. So now it's e to the x equals y minus 1, which means my final answer would be e to the x plus 1 is y. And that would be the inverse. Right? That's how that works. It really isn't. It's just a matter of rewriting when you work with those things. Yes, ma'am. What happened to the log? They undid each other. Just like a second ago, remember we did, if I say log base 6, if I go 6, they just undo each other. Yes, ma'am. Shh, hold up, yes. What's that? The log base e and natural log, they are the same thing. Natural log is just another way of saying log base e. It sounds nicer. Natural. Sounds nicer. It just means natural log stands for log of the natural base. Okay, that's where that came. That's where that came from. Okay. Euler. Euler. Sorry, pronounce it Euler. Euler. And then just one other quick. We'll be all right. So let's see. This is what, section 8.4. I have the PDF is on the calendar already. Let's do a couple rewrites. So this will be on page 490. Actually, let's do it. Yeah, try those out real quick. They shouldn't be that bad. There's a couple of rewrites, a couple of inverse ones, and so on. Yeah, it should be pretty easy. Tomorrow we'll worry about graphing these, and so on. All right.